Yes, it'll be. Yes, you will. You'll be able to look at it. All right. So, starting with our second chapter, we're now getting into kind of the meat of algebra. Okay. First chapter was a lot of real numbers and properties and just kind of that basic foundational work. Now we're actually getting into the process. Hopefully, a lot of this will be somewhat familiar from Algebra 1. Okay? And if that's the case, awesome. If you forgot some of it, that's why we're doing it. Okay? Just try to get those wheels turning again and everything back fresh in your mind. Okay? So linear equations in one variable we're going to start with. Remind me, what's the difference between an equation and an expression?
The equation has an answer or an equal sign.
Okay. Last unit was a lot of expressions. Now we're doing similar stuff with equations. Okay. When we're solving an algebraic equation, we're finding the values of the variable that make the equation true. Find the values of the variable that make the equation true. That may be one number. That may be a bunch of numbers. It may be no number at all. Okay? So we're trying to figure out what can I use to substitute a variable that would make the statement true. Most of the time it's going to be one number. Okay? But there are times where we'll have more than one or none at all. And we'll go over those. Equivalent equations are equations with the same solution set. So we may have different coefficients, we may have different constants, but if they give us the same solution, the variable is the same solution, then the equations are considered equivalent. We have this generic form of linear equations in one variable, okay, x being that variable, but it could be anything. It could be z, it could be y, p, q, k, okay. A variable. And then we have a coefficient and then constants. Okay? Constant on one side, constant on the other. The only rules for the coefficient and constants is they have to be real. And a cannot be 0. Okay? Why can a not be 0? What would happen if a was 0? Then there's no variable. If a is 0, we don't have a variable anymore because 0 times anything is 0. So there's no variable if a is 0. So that's the only rule. A can't be 0. Other than that, all real numbers are fair game. Now, the good thing about equations is they have this property of equality, addition and multiplication. This carries over for division and subtraction as well, because division is just inverse multiplication. Subtraction is just that we can add or subtract or multiply or divide anything we want to the equation, as long as we do it on both sides, okay? Everything has to have kind of equal opportunity, addition or subtraction or multiplication or division on both sides of the equation. As long as we do that, we can do whatever we want. I can add 10 to both sides of my equation, and it's still the same equation. I can divide by 27 on both sides of my equation, and it's still the same equation. We use the property of equality to isolate the variable and get the variable by itself. So we're going to start with these two examples of solving for the variable x and p. Okay? So starting with solving for x. I want to get x by itself. Well, they're not like terms. So, slow down. What's my order of operations? Hold on. Slow down. What is my order of operations? Okay? Parentheses, exponents, multiply, divide, addition, and subtraction. Okay, that's my order of operations. So when I'm simplifying an equation, I'm simplifying an expression, I follow that order, right? Okay, but now I'm not simplifying expression, I'm solving. And solving uses inverses, opposite, which means I need to take this and I need to do it opposite. I need to do it backwards. Okay? So when you're solving for a variable and you're using inverse operations, you need to do the inverse of your order of operations. So you need to look at your addition and subtraction first, then your multiplication and division, then your exponents, and work your way up. Now looking at 3x plus 7, what two operations do I have? I have addition and multiplication. I have addition and multiplication. Which one am I going to undo first? Addition. And then the inverse of addition is subtraction. Okay? So the inverse of addition is subtraction, so I'm going to undo the addition by subtracting whatever's being added. I'm adding 7, so to undo it, I subtract 7. And we have to do that equality. The left side, I'm going to subtract 7. The right side, I'm going to subtract 7. So if I have 7 minus 7, what does that give me? 0. So that goes away. Okay? Because anything plus 0 is still the same. So I have 3x. Okay? Plus 0. I don't need to write that 0, but I want to show you that's what's happening. It's becoming 0. But that plus 0 doesn't change anything. And on the right side, 16 minus 7, 9. All right? So I have 3x equals 9. 3x, 9. Okay? So I undid the addition subtraction. Now I'm going to undo the multiplication with the division. Okay? Divide by 3. Okay? What's 3 divided by 3? 1. So I have 1x. All right? 1 times x. Is that going to change the value of x? No. Do I need to write? No. But understand, that's what's happening. 3 divided by 3 is 1. Now it's that multiplicative identity. Okay? That multiplicative identity. It's assumed. It's implied. But I don't need to write it. Now I have x equals 3. Okay? Or 1x equals 3. So now I know what x is. X equals 3. Now this was in our basic form. We had ax plus b equals c. Alright? See that? We have that coefficient. We have the constants. We have the solution. Alright? The second example is not in that form. It's got a lot more stuff in there. So what can I do to kind of condense it? Combine like terms. Let's look at our left side. What are my like terms on the left side? Good, which gives me what? So I have 3p minus 11. And then what are my like terms on the right? Which gives me what? 18. Good, negative 18. Okay? So again, we're getting a little bit more condensed. Left side's the same, right side's the same. Okay? But it's still not quite the same. What's different?
The variables are different.
Yeah, I got 2 variables. They're the same variable. We got 1 on each side. I need them on the same side. Okay? So always move the smaller one. General rule of thumb. Move the smaller one. So I want to move this one. Now, I want you to make sure and you pay really close attention to this. Okay? Because it's a common mistake that happens all the time. And I'm emphasizing it because it's a common mistake that happens all the time. What did I do to get 3x by itself? I divided by 3. Okay? To get x by itself with 3x, I divided by 3 because 3 and x are being multiplied, right? But here, I want to move the entire thing of 2p. So what is 2p doing with negative 18? It's being added. 2p is being added to negative 18. So how do I move something that's being added? Subtract it. So because I'm moving the entire term, I subtract. If I wanted to separate the coefficient from the variable, that's division. Moving the entire term is addition or subtraction. Separating a coefficient from its variable is division. All right? So the whole thing gets moved. That gives me 0, and then this gives me p minus 11 equals 18. So now I'm down to that one variable. And my last step is going to be what? Add 11 to both sides. So if I add 11, I get p equals negative. All right. Now, we found these solutions. Yay! Good for us. I got p equals negative 7 and x equals 3. Okay? All right? And then your next quiz comes up. You do the work. And I've got some extra time. I'm not sure if these answers are right. What can I do to check? Plug it back in. Say, okay, well, I'm saying that if x was 3, this should be a true equation, right? So I could say, well, all right, so 3 times 3 plus 7 should equal 16. So 3 times 3 is 9, plus 7. Hey, yeah, that does equal 16. I know my answer's right. And that took a grand total of like, what, 10 seconds? All right, so take time, double check your answer, and if you get something different, then take the time to look and figure out where the mistake was. All right. Questions on either of those? You have 5 minutes to answer this question. Take your time. Okay? Take your time. Combine your like terms, and then do your inverse operations. You will get a fraction or decimal answer. I want you to write it as a decimal, please. Decimal answer. Please write a decimal answer. It should be pretty simple addition and subtraction. You got 5 minutes.
I just don't know.
You got your space on that blank slide to write. And then keep going so that you X by itself. So you can have equal 0, but now move your constant to the other side.
So I would put the X on one side and the other side.
The other side. Yep, and then get X by itself. What is happening with 20 and X? What are they doing? Okay, so you want to do multiplication. Both sides. Other, that's what we do. Why don't you try it again? I know you're going to do here. Make sure you know yourself. That's fine. It's better to make that mistake now and learn from it than hold on to it.
Add 30, so 24 equals 10. And then do I put 24 on the 2? It's just subtract around.
Just when you put in your answer, just put the number. You don't need to put X equals. Yeah.
I might have. You can't. You got the wrong answer. So literally proclaim that like
I don't know.
So yeah, you got those.
Subtract or
Yeah, I did.
you subtract. So what do I do?
I'll just do it. I'll not explain it.
Woof. All right. Oh, that's not what I wanted. So what do I do first? Actually, let me do it here. Okay? Combine like terms. Okay? And this is an important distinction because I kind of heard this conversation a little bit around the room. Okay? When you're on one side of the equation, okay? Everything's on one side of the equation. You're combining like terms. You're not doing inverse operations. I have 12x and I have 8x together. I have how many x's? 20. Okay? The only time I would subtract that if I wanted to move it from one side of the equal sign to the other side of the equal sign. But if I'm staying on one side, it's just considered combining like terms. Same thing with the 30 and the negative 6. If I have 30 and negative 6 on the same side, it becomes 24. Okay? Now that I've combined my like terms, I'm working towards get x by itself. So what am I going to move to the other side first? The 24 by doing what? Subtraction. Okay? So minus 24 on both sides. 20x equals negative 14. Okay? Alright? So again, same side, just combining like terms. So we're not changing any operation. When we move to one to the other, that's when the inverse operation starts. Okay? So let me kind of label. This was combining like terms. That was that first step, and then we used inverse operations. Okay? So always want to combine like terms first. You won't always have to combine like terms. You may get an equation that starts in this form of 20x plus 24. Okay? If that's the case, you don't have to combine like terms. But here we did, then we apply inverse operations. 20x equals negative 14. Now I do what? Now I divide by 20. And again, that's another inverse operation because we're going from one side of the equal to the other side of the equal. So we're going to divide by 20. 20 divided by 20 is what? 1. So I just end up with 1x. And then 14 over 20 reduces to negative 7 over 10, which as a decimal, negative 0.7. Okay? Questions, comments, concerns? What's that?
How do you know if
So the goal is, after you combine like terms, your goal is to get everything away from your variable. So you can subtract 10, which is fine. You're going to get, what is it going to give you? It's going to give you 14. But then you're going to have to move. So if you wanted to subtract by 10, that's fine. You'd have 20x plus 14 equals 0. But now your goal is, well, I need to get x by itself. So now I still have to move the negative 14. And then you end up at the same place that we were here. So it's saving a step. So once you get things simplified and they end up in that ax plus b equals c kind of a form, once you combined all your like terms and you only have one variable, your goal is to then get everything away from the variable. So whatever steps you can do to move anything that's on one side to the other away from your variable. Okay? Any other questions on that? All right. Now, so now we're going to add in a little bit more complexity. Again, it's the simplification before we do those inverse operations. All right, so we started with inverse operations. Then we did combining like terms, okay, which is our commutative property. What property do I have here? Distributed. So I need to distribute first before I combine like terms, and then inverse operations. So what am I going to distribute? 5 into what?
5 into 3.
Okay, so 15 plus 5z, good, okay. And then what else am I going to distribute? Negative 1. So I get negative 8z minus 9 equals negative 4z. Okay? Now, we want to combine like terms. We want to get our variables together on the same side, and then use our inverse operations. Okay? Any questions on how we got from here to here? Ask it now. Ask it now. So remember, so I have this entire thing is being subtracted, right? So this is saying, hey, this is distributed property. So the identity of the multiplicative identity says if I don't see a number there, I can assume it's a negative 1. And so I'm distributing the subtraction to all parts, which changes the sign. So looking at it as a negative 1, I'm now changing this positive to negative and this positive to negative. Because I need to subtract 8z and I need to subtract 9. Yeah, and if for a similar example, if I had plus 8z plus 9 in parentheses, I can still put a 1 there and distribute that. Well, 1 times 8 is still 8z, and 1 times 9 is still positive 9. So you can put that assumed 1 there, distribute it, and that gets rid of those parentheses. If it's a positive 1, it doesn't change anything, but if it's a negative 1, it absolutely does. Yeah.
Yeah, so just to clarify, if that was a negative 9, it would still be plus negative 9.
If this up here was negative 9,
I mean like that down there.
this down
We're
here,
adding
yeah. So if this was minus 9, again, it wouldn't change the sign. So if I had plus 8z minus 9, is that what you're asking? Yeah. So then again, I have the 1, I distribute, I still end up with 8z minus 9. Yeah. Yep. Okay. And if this was negative, then it would change it from negative to positive. Okay. So we're just doing that multiplication. All right. All right. So you guys are going to finish and put in your answer. Okay. Just the number. Just the number. That's all I want. What does z equal? Huh? 1 minute. I'll show you the last step in just a second. Not bad. All right. So we distributed. You'll see. Okay. So what's my next step after I distribute? Okay. Yep, so we want to combine like terms. 5z and 8z gives me negative 3z. Do I have any other like terms?
15.
Which gives me what?
6.
Okay. Now what? Add 3z, because we want to get all of our variables together. So plus 3z plus 3z. That equals 0. So I have 6 equals negative z. Negative 1z. So now I still need to get z by itself. Divide by negative 1. Negative 6 equals z. Okay? Careful with those negatives. Every time. Every time. Alright? Questions, comments, concerns? Now, these are all the steps of solving a linear equation. We just did 2, and then the last few examples had 3, and all of the examples had 4 and 5, and then we talked about checking your answer. Now we're just adding in one more check. Francesca. Jojo, you know these are online, right? You don't need to take a picture of them. Yeah. Sometimes we get fractions. We need to get rid of those fractions because no one likes fractions, right? Who likes fractions? Okay? I feel bad for fractions, but no one likes fractions, so we need to get rid of the fractions. What operation is a fraction? It's division. Okay? A fraction is division. If you've never known that, let me show you something. The division sign is just a fraction with dots for numbers. I know. Okay? So, fraction is just division. Alright? So I need to get rid of that division. I need to get rid of that 5 in the denominator. So how am I going to get rid of dividing by 5? I'll do that. Multiply by 5. Okay? I'm going to multiply everything by 5. Okay? Now, just to make things a little neater, let's go ahead and distribute this numerator just to make it a little bit cleaner before we do the multiplication of 5. Okay? So 3y plus 9. We're going to do this. Okay? Just to clean that up. Just to make it a little bit neater for us. Okay? So I have that. And now I want to get rid of that division by 5. Okay? By multiplying by 5. So the left side is being multiplied by 5. And the right side is being multiplied by 5. Okay? The left side is being multiplied by 5. And the right side is being multiplied by 5. Okay? I put parentheses here and I got the 5 on the outside. So what property is this now? It's distributive. So we're going to distribute. Okay? Here. So on the right side, I'm going to end up with what? Okay? Now on the left side, magic trick. Are you ready? Remember, because I see this mistake a lot, you guys look at this, you go, oh, we'll multiply the top and the bottom. No, I'm not multiplying the top and the bottom. Yeah, so I'm just multiplying the top, because this is like 5 over 1, right? I don't need to actually distribute, because what's going to happen with the 5 and the 5? Cancel out. 5 divided by 5 is 1. You can distribute, you're just going to have to end up simplifying later, and then your denominator's still there. Okay? So the 5 and the 5 will cancel out, leaving us with just our 3y plus 9 equals 10y plus 30. Alright? So now we've cleaned it up. Now it's back to something that we're more used to. So now what? 10y minus 3y. Let's go ahead and subtract 3y. Okay? So 10y minus 3y gives me 7y. So let me write up here, I got 9 equals 7y plus 30. Track 30. So I get on the left side what? Good. Negative 21 equals 7y. And then I end with divide negative 3 equals y. And if I was unsure about that answer, what can I do with that negative 3? Plug it back in. Right here? Okay. So my property says that I have to do the same thing to both sides of my equation, right? I'm multiplying by 5 to get rid of this division by 5 here. So the left side is being multiplied and the right side. What's important to remember is that everything on the left side and everything on the right side needs to be multiplied by 5. Okay, so that's why I have that. Okay? The entire left side is being multiplied by 5. So boom, 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 everything gets it. Same thing on the right. Okay? Good question. Any other questions? Okay? But I'll go ahead and start talking about the next slide. The next slide talks about different types of solutions. Okay? Everything we've had up until now has been what we call a conditional solution. How many answers have we had? 1. We've had one answer for every single equation that we have. It's called a conditional equation. One solution. Okay? There will be times, and you'll see an example in just a moment, where we'll have an equation where both sides end up being the same exact thing. Okay? So we call those, actually I skipped that one. We'll have something that's a non-true statement. Okay? We'll end up with something that's non-true. And we call that a contradiction. And it could be something as simple as 2 equals 7. Is that a true statement? No. 2 does not equal 7. Okay? So that's a contradiction. And what that means is that it doesn't matter what number we plug in for x, we're not going to get a true statement. Okay? There is no solution. There is no solution. Okay? So conditional is one solution. One solution. Contradiction, no solution. Doesn't matter what number I plug in for x, I will never get a true statement. And the last one is called an identity, in which we have every solution. And when we have an identity, what's going to happen is we usually end up with a statement that's always true, such as 2 equals 2. Well, yeah, no duh, it's the same. 2 is always going to equal 2. Doesn't matter what number we plug in for our variable. Or maybe even I have 2x equals 2x. It's always going to be true no matter what number I plug in for x. I will always get a true statement. That is an identity. Okay? So let's look at a couple examples. One will be a contradiction and one will be an identity. Looking at the equation on the left, what do I do first? Distribute. So I have 3x minus 7 equals 3x plus 3. Okay? Now, combine my variables. What do I do? I'm going to subtract 3x from both sides. Okay? Well, what's 3x minus 3x? 0. I don't know why that's plus. Disregard that. Whatever. Negative 7. Okay? Is negative 7 equal to 3? No. Okay? It's a contradiction. No solution. No solution. Distribute, combine like terms. 5x minus 5x equals 5x minus 5x. No duh, they're the same thing. Of course they're going to equal each other. So this is instead going to be a identity. Which means I could plug in any number for x, and it will always be true. So the solution is all real numbers. All real numbers. Because I can plug in anything for x, and it's going to be true. Okay, all real numbers. Now, side note, because it's our last slide, but I want to talk about this because it always shows up. You're working an equation. You're solving an equation, whatever it is. Okay? Can I do a blank one? No? Okay. Okay, you're solving an equation and you end up getting x equals 0. Okay, this is separate from these conditional statements, blah, blah, blah. And you get x equals 0. Is that a conditional, contradiction, or an identity? If I work an equation, I get x equals 0. Not a contradiction. It's conditional. It's an answer. 0 is allowed to be an answer. 0 is a number. It's a whole number. It's an integer. It's a rational number. It is a real number. So for the love of all that is good and holy, guys, listen, because I guarantee one of you is going to make this mistake. If you get x equals 0, that's fine. X is allowed to be 0. 0 is a number. Okay? Have a great day. Okay.